Okay, so we have, this is important terms, okay, regarding the error. First one, the true value. Okay, true value. It is AV minus A. AV means approximation value. Approximation value. So I'm using short form here, okay? Okay, the E refer to the error value. Error value. Okay, so TV true value, that is equal to approximation value minus E error value. So this error value can be positive or negative. Okay, so next term we have this symbol represented by epsilon T. This symbol is called, this is a mathematical symbol, is called epsilon. Okay, so epsilon T is equivalent to value of error divided by true value, and we are taking the absolute value times 100%. Okay, so epsilon T refer to the relative error. It's called relative error. Relative error. Okay, so this symbol means absolute. So if our calculation inside here is negative, so you have to remove the negative, evaluating only to the positive. Okay, that is the meaning of absolute value in this calculation of relative error. Okay, next we have epsilon A. Okay, so this epsilon A is the absolute error. A means absolute error. Okay, so there are two different formulas for evaluating the absolute error. The first one is based absolute error divided by, okay, it's not absolute error, it is approximation error. Approximation error divided by uh, approximation value times 100%. This is first formula. Okay, so AE is called approximation error. AV is this one. AV is this one, approximation value. Okay, so this is first formula. Second formula for evaluating the absolute error is based on this formula. Okay, so CA is called current approximation value. Current approximation value. PA means previous approximation value. Okay, so since there are two different formulas, okay, for this absolute error, which one to use is depending on the situation. Okay, so what kind of information that we have in the situation, then we apply the formula. Okay, so if in the situations it contains the approximation error and the approximation value, so we'll be using the first formula. Okay, so if there is a questions regarding some kind of number of iterations, so we'll be using the second formula. Okay, so this second formula will be commonly used if we have problem in related to the iteration. Okay, there is some repetition of the calculation, then we'll be using the second formula. Okay, so next we have this estimated error, ES, okay, epsilon S, okay. So it's called estimated error. Epsilon S. So it's given here 0.5 minus, minus times 10 to the power 2 minus n percent. Okay, so estimated error, this is the symbol, right? Yeah, this is meaning estimated error. So this n refer to the number of significant figure. Okay, n significant figure. N significant figure. Okay, so estimated error means that the error that we might accept on the problem. Okay, so this is the formula. Okay, for example, in certain situation, we will consider based on plus and minus 0.005, depending on the decimal places on or significant figure. Okay, but when it's related to the significant figure, it's already counted the maximum error that it can be. Okay, in that situation. Okay, so we have formulation 0.5 times 10 to the power 2 minus n refer to significant figure. This formula cannot be used for decimal places. Okay, so estimated error is our value that we are going to compare if we want to stop the calculation in the iteration. Okay, so usually our current current approximation value should be less than this estimated error. Okay, should be less than. So on different question, okay, on different situation, estimated error is given or it can be not given. So if it's not given, then we have to use this formula. Okay, so do you have a question here about these important terms and formulation relating to the error? Okay. Okay, so for the second cell O in ebook 1, so it is in this page. Yeah? Okay, so bracketing method is the same meaning with the close method. Okay, so these are the method. But I want to start with the bisection method. Okay, bisection method. So this bisection method in the ebook is on page 100. Okay, 1 to 4. Okay, but actually the one that in bracketing graphical method, the example are based on the same function, one type of function. Okay, so but this graphical I'm going uh, to show to you. So this is a function. Wait, yeah. Yes, kaide, yeah. Symbol. So symbol, yes, for all methods. It's not only this method, but few of them will be used on the next chapter, chapter 3. Okay, symbol, the symbol that say absolute A, so means that absolute error, the symbol. But on different chapter, let's say chapter 3, the meaning or the formulation will be a bit different. Okay. Uh, Chapter 3 is on numerical integration and numerical differentiation. So the meaning for the absolute error will be a different one. Okay, so the formulation that I stated uh, just now is based on the one that will be applicable in second cell O, okay, second chapter. Okay, so the examples that I want to show is actually, or the method is on the bisection. Okay, for this graphical, I will let you to verify now. Okay, graphical method is the method that we use by sketching. So we sketch the graph for the function. Okay, so for the example, this is nonlinear equation of function. Okay, the first one, the one that I highlighted here, this is the nonlinear. Okay, so the first equation is being transformed to this one. What is the difference? Only this one, simplify. Directly times out with 10. Okay, so the one that will be work in the example will be based on this one. Okay, the second one. Okay, so if graphical method, I will just explain, but I'm not showing to you the example. Okay, it's like how we sketch a very simple graph, two-dimensional graph. Okay, so if we have this kind of function, these are nonlinear. Okay, so how to solve this equation? How to find out the true value? Okay, in this problem, the true value is given. Okay, the value is true value is given as 14.7802. Okay, true value 14.78. Okay, I will check later on. How the thing speak. Okay, so 14.7802 is given in this situation. Okay, but this one we have to show the value based on the graph. Okay, graphical method. Okay, so for sketching, we are supposed to start with the table, like this table, but this is not enough actually. Okay, so there are 5 pairs of points between C and FC. Okay, okay, true value just now, the true value is 14.7802. This is true value. Okay, so you can check that the true value 14.78 lies in these two. Okay, 14 is here. So 14 is between 12 to 16. Okay, so when we applying the graphical method, you are supposed to have table containing your C and FC. Okay, so in the table, you must have 10 set of points. Okay, so you are supposed to choose C value. Okay, that is between 14.7802. This one you have to find out. Okay, the true value, how to solve it? if it's a linear equation, then you can key in, right? If it's three variables, so you can key in the equation. So for the non-linear, you have to solve by let the FC equal to 0 and solve it. Solve for C. Let FC equal to 0, in this case, solve. Okay, but usually then true value for the non-linear functions are given. But if the non-linear function is very simple, so usually the true values will not be given. But if it's not given, then you have to know how to find out. Okay, so let the FC of fx equal to 0, then solve for x. Okay, so in the graphical methods, you are supposed to choose suitable value. So like this one, they are choosing 4, 8, 12, 6, 20. But in the table, it's not enough. So you are supposed to have additional 5 more values. Okay, so you can extend. And add another 5 values. Okay, so once you have, okay, so you can start by plotting the graph. So the x-axis will be your C, the y-axis will be your FC. Okay, so select what is the suitable scaling for C. Okay, you're supposed to have 10 here, then it's 10 also, okay? Depending on this one. Okay, so next plot, let's say 4. Okay, let's say I have this kind of scaling as 4, then I have 34.15. Okay, so you just plot like this one. For example here. Okay, so once you have the set of point, then sketch. The graph should not be sketched linearly. Okay, so means that you cannot use a straight line to connect the points because it is non-linear. Okay, so you have to use your curve. Okay, sketch by using the curve. Okay. For this true value, can check here when you substitute into the true value 14.7802, so your FC will be 0. Is the way how to check is this a correct true value or not. Okay, substitute into your original equation. Original equation is this one. Okay, substitute here. Okay, so when we sketch the graph, okay, this is actually the graph. Okay, so this is actually the graph. So this is the point 14.7802. Okay, this point, the dot black color here is the root. So the root is the solution. Okay, solution for the this kind of function FC. So you can check this one. The FC is 0. Okay, so the value here is 14.7802. This is in if we plot the graph, sometimes it's not we're not able to get exactly 14.7802. Should be close. For example, you might be getting 14.5. Okay. So there are some range that we are going to accept depending on your graph, scaling of your graph, okay, on the x-axis. Okay, so in the graphical method or using true value, let's say in graphical method we have 14.5. Okay, 14.5 in graphical method. Using graphical method, for example, so we have the approximation value as 14.5. Okay, so true value is 14.7802. Can check, it's difficult for us to sketch. Okay, to sketch and get the value in the form of 4 decimal places like this. Okay, So probably you might be getting 14.5. Okay, so if we want to find uh, the error, okay? So for example, just now I showed to you the formula true value is equal to approximation value minus E. Okay, so the error between these two will be 14.7802, that is equal to 14.5 minus E. So you can check what is your E value. Okay, you can check. So uh, this we call this error as the error for this calculation. Approximation value is the one that we conduct using graphical method. True value is this the exact value. Okay, so for special method, special special types of graph. Okay, so I'm going to show to you the basic graph for this non-linear. Okay, so first one, this kind of graph like this. Okay, let's say it's in terms of x and xy. Okay, so this equation will be y equal to the e to the power x. Okay, this is exponential e to the power x. So e to the power x is non-linear. This is basic graph. So whenever if we want to plot the graph, make sure you have to know what is the basic graph. Okay, for example, the equation might be given, let's say e to the power 5x. Okay, so you already know what is the pattern for the basic graph. Okay, like this one. The difference only will be this point probably you might be getting like this one. The difference might be like this. Okay, okay, like this one. Or you can have like this one, for example. But the basic graph you have to know. Okay, so next we have graph based on this one, like this. This is graph based on ln x. Okay, so don't forget when you want to sketch the graph, make sure label the axis. Okay, and then we have this one, very simple. You already know this part. This is quadratic equation, okay? Or we can have like this. Same types of equation. The difference is the value of A. Okay, this condition when A is positive. This one when A is negative. Okay, we might be getting a different kinds of this. This is against a different axis. Okay, so like this one. The subject will be different. So this case when we have A positive. Okay, or we can have like this one. So the equation is x. This is when A is negative. Okay, and then the types of function. Is this cubic equation? Okay, two different types. One is A positive, the other one is A negative. Next, we have this kind of function. So the curve is on quadrant number 1 and 3. This is quotient function in terms of this one. This is when C positive. So when C is negative, we're getting different quadrant like this. Okay, so next we have for the circle equation. This is the radius of the circle. So the equation will be written as x minus a okay, so this is a point of AB. In this case, the AB is 0. Okay, so AB is the point uh, at the origin. Okay, they're representing the radius. Okay, so next we have this kind of graph. We call this as ellipse. So this is a point B, this is negative B, this point negative A, this point for A. So the equation for the function is this one. Okay, so this is ellipse function. Okay, then this is the last one. So this one, this is hyperbolic function. Okay, so base is here. Okay, and the question here. Taroma, you lambat masuk kan? Nanti you tengok video. This is not about graph only. I already explained about methods in this one. Okay, so next we proceed to the bisection. Okay, so the bisection is on this page. So this is the step for the bisection. Okay, but I will make it the steps very simple for you, so that it's easy for you to follow up on the in the methods. Okay, so I will directly goes to the example. For this bisection. Okay, this is the guide. First one, calculation for C. A plus B divided by 2. C is called as the middle point. Okay, so then we have A, FA times FC more than 0. So the set A is C, B is B. Then if we have FA times FC, that is less than 0. Then we have A as A, B is equal to C. So this one is the one that I simplify for you. Okay, so the one in the ebook, I'm using FA. So the one in the ebook, they are using XU. Okay, this XR is the C. Okay, XR is the C. So I prefer to use very simple symbol. Okay, as this XR means the one that I put down here is C. So it's the same formulation. Okay, and then this one on this is step. Then this XL is our AB. Okay, XL is means a lower value. We call it as A. Okay, XU means upper value. So I'm using label as B. So C is equal to A plus B divided by 2. Okay. So the changes will be like this one, the same thing, but it's actually the same meaning. So FXL. So XL means FA. This is FC, less than 0. Okay, so this is the setting. So this is actually the same thing. Okay, same thing that how I label that one. Okay, but this is the explanation for step 1. We don't have basic formulation, but the first step is to start the calculation with the interval containing the true value. Okay, interval containing true value. Okay, I will go back to the table just now. Okay, I already highlighted this one. 12, 16. So you already knew that the true value just now is 14.7802. Okay, so we will start the interval for bisection method using 12, 16. Okay, so that is the explanation for step number 1 just now. Okay, so step number 1, choose suitable interval that contains the true value. Okay, cannot choose 8 and 12 because 14.7802 is not in this interval. Okay, so 14 is between here. So same goes, cannot choose 16 and 20 because between 60 and 20 does not contain 14.7802. So the interval that we can choose only is between 12 and 16. Okay, so this 12 will be your A. 16 will be your B. Okay, so in the ebook, this is using XL. This one is XU. Okay, XL, XU. So I'm using here A, B. Okay. Any question before we start the calculation? Okay, so what happened when you choose, let's say you choose 4, 8 to start the calculation. Your calculation in the numerical table will be diverging. Okay, not converging. Diverge. Okay, it's called diverging. So we are supposed to have the calculation that is converging to the true value. Okay, so we choose here 12, 16. Okay, now can we choose 13 and 16, 13 and 16? Okay, you can choose 13 and 16. No problem if you want to choose. We can choose 13 and 15 also because 14 is in the middle one. Okay, true value is in the middle. Okay, so first step must choose two values as the interval. Okay, so we call that one as A, B. Okay, so between A, B contain the true value. Okay, so next we have the numerical table. So the table will be like this. We have, I hope you have the calculator with you now. We have A, we have B, we have B, then we have C. Okay, so then we choose the symbol. Okay, so the symbol will be this one, FA times FC. Okay, I'm going to show some calculations only, but you have to complete the table. Okay, for this bisection, okay, for this bisection, the stopping criteria will be based on your value of absolute error, that is must be less than your estimated error. So in this function, the estimated error is given as 0.5%. Okay, so our stopping criteria for this method, stopping criteria means when to stop the calculations, okay, the one in the table. When our absolute error is less than estimated error. Okay, so in this case, we must have additional column, estimated error. This column for absolute error. Okay, so just now we already decide that we want to choose 12, 16. So this will be your 12, 16. Put it here. Can we start with 13 and 15? Yes, you can. So this your A will be 13 and 15. Okay, we can have 13 to 14.5 also. No problem. Okay, but this one I'm just showing to you the example. Okay, so we calculate first one using this formula C. C is equal to A plus B. So means that for this value, it is 12 plus 16 divided by 2. Okay, so then we have 14, correct? Okay. Okay, so we now this column have to make sure FA, this means that we have F12, okay, times F14. Okay, this column only taking the sign. So I want to see whether it's a positive or negative, okay, positive or negative. Okay, so I'm going to refer to the table because the table is given, this table is given, okay, so I'm taking here F12, this is 12. So F12 is positive, right? Okay. Symbol is positive. This is positive 6.067. Okay. So I will write down here F12 is positive number. So I'm going to write down just positive. Positive symbol. Okay, so you need to find out what is F14. F14, substitute into your original function. This one, substitute 14 here. Okay, so I want you to calculate now. Okay, so give me the numbers. Just type the numbers. Type the numbers. Okay, so this one will be times 14. Calculate it now and then type your numbers. F14. Substitute here, it is 14. This is 14 also. Positive, huh? 1.5687. Okay, so I'm going to write down 1.5687. Will be this is F12. So the number is positive. Okay, so I'm just taking the sign because it's positive number, positive. Okay, so positive number times positive number, okay, is positive, correct? Okay, positive. Positive number times positive number. Okay, so I will just conclude. Okay, I will just conclude like this. I'll just sketch it. It's positive. Positive number times positive number is positive. Okay. The first part here, there is no absolute error. Dash. So it just we label it as dash. Okay, so this will be we need to make sure once we have identified this, which one that we are going to get. Okay. Since we already find out is positive, we'll be using this part. We cannot use this one, because we have find out this is positive. Okay, so in the next calculation, your A will be your C. This one, this is meaning your A, your A, your new A in the next calculation will be C. So we have 14 here. Okay, so B remain the same thing. B remain, B is B, so no changes. So we have 14, 16. Okay, so calculate new value C. Okay, so new value of C will be 14 plus 16 divided by 2. So we have 15. Okay, so then find out what is F14 times F15. Okay, so we have this one as, you can check, I will just proceed. Positive times negative. Okay, so positive number times negative number is negative, right? Okay, so I will just conclude this as negative. Negative, I will just write, I type positive. Okay, negative. I'll just conclude negative. Okay. So next one, calculation for the absolute error. Okay, for this calculation, for this column, We'll be using current approximation value minus previous approximation value divided by current approximation value. It will be based on this column. So the first calculation dash. Okay. So second calculation will be 15 minus 14 divided by 15 absolute value times 100%. Then I have 6.67%. Any calculation? Any question up to this step? What do you mean net zero? Semua macam tu saja. Okay, so now at the second calculation, let's look at this is negative, right? It's negative. Okay, so because this is negative, we refer to this condition because it's negative. More than zero means that this is positive. Okay, less than zero means it's negative. Okay, so we use this one. So in the third calculation, your A just now in the second calculation remain the same thing. Your A is 14, remain same thing. This is 14. So B is C. So update your B 16 need to change to 15. Okay, so your C will be 14 plus 15 divided by 2, then we have 14.5. Okay, so can check later on F14 times F14.5. F14 is positive. Okay, times F14.5 is also positive. Okay. Then we'll conclude that positive number times positive number, then this one is positive number. Okay, so next. The calculation for the absolute error will be 14.5 minus 15 divided by 14.5 absolute times 100%. So this one you will get 3.45%. Yeah, I will just put label here, percent. 3.45%. Okay, so let's look at in the second calculation. Your second calculation is 6.67. 6.67. The third calculation 3.45. Okay. We still get that the absolute error is more than the estimated error. Still more than. This is estimated error. Okay. That's why we have to continue the calculation. Still need to proceed the calculation. Okay, so let's look at in the third calculation we have positive. Okay, we have positive. Okay, because it's a positive, we use this one. Positive, so A is C. Your A need to change 14.5. Your B is B. So remain 15. Okay. So this one I want you to complete the table. Okay. Complete this numerical table and I will check the completed table, the completed value in the next class. Okay, so you have to stop the calculation when this absolute error is here, the value is less than 0.5. When it less than this value. Okay, once it is the value, once the value is already less, first time is less than 0.5, then stop the calculation. Okay, so I want to know what is the C value at this. That is our approximation value. Okay, so the last value in column C will be the approximation value using bisection method. You can use symbol, you can use symbol, you can use symbol this one, more than. You can use less than. So I want to use this one, positive. So less than means that negative because it's a comparison between more than 0 and less than 0. Okay, you can use either symbol, either one symbol. Okay, any other question? Substitute value. Substitute value after already that. So you have to substitute value in your, in this case it's a function. Substitute inside here. Substitute this one. Is it 40.5? So substitute 40.5. So this one 40.5. So if you want to find out for 15, so change this C to 15. So change this 15, okay? So we get the value. Any other question? Okay, so this one don't forget, complete the table. I will check on the next class. Bisection this one, but bisection is that one, but I will list down the tutorial questions and then inform to you later on. We will do comparison. We will do comparison between bisection, force position, and other methods. Okay, so I will update the list of tutorial for you to complete. Okay, so don't forget for those who haven't submit the checklist, please submit by today. Okay, so if there's no question, then we dismiss the class now. Any other questions? So there are 4 students haven't submit the checklist, so don't forget submit by today. Okay, so thank you everyone.